Hi friends, welcome to the tutorial series of distributed operating system by Goanboy tutorials. In the last tutorial, we have seen various classification of distributed operating system, tightly coupled and loosely coupled systems. Today we will see various bus and switch architectures, software concept of distributed operating system. Under this we have network operating system and true distributed system. Under bus and switch architecture, we have interconnection networks. Under this we have bus-based multiprocessor, switched multiprocessor, bus-based multicomputer and switched multicomputer. Now we will concentrate on this part of the taxonomy. First we have bus-based multiprocessor. It has some number of CPUs all connected to the common bus along with a memory module. Bus has 32 or 64 address lines, data lines and 32 or more control lines. Suppose we have two CPUs, CPU A and CPU B. And CPU A writes a word to the memory called X and CPU B reads that word in some microsecond. The CPU B will get value just written. This property of the memory is called as coherent. Bus-based multiprocessor has a shared memory. Problem with the previous scheme is that if there are 4 or 5 CPUs, the bus gets overloaded and performance drops. Solution is to add high-speed cache memory between CPU and the bus. Cache holds most recently accessed word and all the memory request goes through cache. If the word requested is in the cache, cache itself responds to the CPU and no bus request is made. If the cache is large enough, the probability of success, that is hit rate, is high and traffic per CPU will drop. Next we have advantages and disadvantages of cache memory. Advantages: it is faster than the main memory. It stores the data for temporary use. If any request has been made by the CPU and that response is already in the cache, cache itself responds to the CPU and no bus request is made. Disadvantages: limited capacity and it is expensive. Next we have Snoopy cache. All the caches constantly monitor the bus. Whenever the cache sees a write occurring to the memory address which is present in its cache, it either removes that entry from the cache or updates the cache entry with a new value. Such cache is called a Snoopy cache because it is always snooping on the bus. बस की बात हो रही है तो बस कंडक्टर का एग्जांपल लेंगे. Whenever the any passenger enters in the bus conductor repeatedly checks to see if he issued the ticket. Same way, Snoopy cache checks to see if any new entry is made into the cache. If it is made, it updates with a new value. Design consisting Snoopy write through caches is coherent and invisible to the programmer. Next we have switch multiprocessor. These are the method to connect CPUs to the memory. First method is crossbar switch. One possibility is to divide the memory into the modules and connect them to the CPUs using crossbar switch. In figure, each CPU and the memory has a connection coming out of it. At intersection, there is an electronic crosspoint switch which can be opened or closed in the hardware. Whenever CPU wants to access any memory, this switch is closed in order to allow the access. If there are n CPUs and the n memories, then n square crosspoint switches are needed. This approach is expensive. We have the second application, which is omega switching. Network contains 4 2x2 switches. Each switch has a 2 inputs and 2 outputs. Each switch can route either input, either output. Meaning of this is, each switch can route available input to available output. If there are n CPUs and n memories, omega network requires log to the base 2n switching stages. This is expensive plus it is slow. The next is bus-based multicomputer. Multicomputer is a collection of workstation on LAN. Each CPU has a direct connection to its local memory. Here we can see each workstation has its local memory and the CPU and all are connected to the network. Since it is CPU to CPU connection, there will be much less traffic as compared to CPU to memory traffic. Here, lower speed lane is used, typically 10 to 100 Mbps. There is no shared memory present here. Switched computer. CPU has a direct access to its own private memory. First example under switched computer is grid. They are easy to lay out on the circuit board, and these are best suited for problem with two-dimensional nature such as graph theory. Next we have hypercube as a second example.
Hypercube is an n-dimensional cube. CPU has a n connection to the other CPUs. It is represented by two ordinary cubes having 8 vertices and 12 edges. Vertex is denoted by the CPU and edge is denoted by the connection between two CPUs.
Next we have software concept. Loosely coupled software allows the machine and the user of the distributed system to work independent of each other, but they still can interact when there is a need. Example: the personal computer having its own memory and the CPU, but they share some resources such as printer or databases over the LAN. If the network goes down for some reason, individual machine can still continue, although some functionalities will be lost. Under software concept, we have network operating system. It is built using distributed system from a network of workstation connected by using a high-speed network. Workstation is nothing but a nodes, and this is connected by the high-speed network. Each workstation is independent computer with its own OS and other resources like hard disk, file system and databases. It follows loosely coupled architecture. If you remember this Teda-Meda diagram, then you can produce point for network operating system. This is an official diagram of network operating system. As we said, there is a machine A, machine B, machine C. This machine has a common distributed application. Each machine has its own network OS and the kernel which is connected to the common network. Now we will see example of network operating system. There are two clients and one file server. User of the workstation takes a remote login to the server and execute the remote command over the network. Network operating system is a centralized file storage system. Now we will see commands to take login in another workstation. The command is rlogin machine to copy the files from one machine to another machine, that is from machine 1 to machine 2. The command is rcp machine 1 file 1 machine 2 file 2. Next we will see advantages and disadvantages of network operating system. Advantages: there is a scalability feature, that is large number of resources and users are supported. Disadvantages: it fails to provide single coherent view. Coherent view refers to the consistent view. These advantages and disadvantages are not clearly mentioned in the book, but they are asked in semester, you can note it down. Now we will see client-server arrangement in the distributed system. Now we have two clients, client 1 and client 2, file server, server 1 and server 2. Two file server has a directory name as game and work respectively. Client mounted the servers but in different places. Client 1 mounted games and the work in the root directory and can access them as /games /work. As client 1, client 2 mounted games in his root directory. But while reading the mails and the news as a kind of games, has a created directory /games /work and mounted work there. The conclusion of client-server arrangement is that it does not matter where the client mounts a server in a directory. But it's important to notice that client can have different view of the file system. Next we have true distributed system. This is tightly coupled software on the same loosely coupled hardware. Goal is to create illusion in the mind of the user that entire network is a single time sharing system. Some characteristics that should be observed in two distributed system are: process management must be same everywhere. Process started, destroyed, created or the stopped must not vary from machine to machine. File system must look same everywhere. If the file name is restricted to 11 character, it should not be unrestricted in other places. Semester question. Explain the various bus and switch multiprocessors and the multicomputer. What is a Snoopy cache? Explain the software concept. What are the advantages and disadvantages of network operating system? Explain the client-server network operating system. Explain different client-server mounting. What is a true distributed system? Explain the characteristics of the same. From hardware and the software concept, most of the module 1 or the unit 1 question are picked. So more weightage is given to this topic, that is hardware and software concepts. In next coming tutorial, we will cover design issues of distributed operating system and various transparencies. So you subscribe to my channel, share with your friends, comment down below if any suggestion are there. नोट्स का लिंक मैंने डिस्क्रिप्शन में दिया हुआ है, तो मिलते हैं नेक्स्ट ट्यूटोरियल में।